Okay guys, today we're doing 4.8 absolute max and mins with intervals, okay? Every time they ask you an absolute max or a min, it's going to have an interval that you're going to be looking at. So let's get started on this. Okay, first thing, let's just answer this warm-up. If f of x is increasing, then f prime is greater than 0. We answered these last time too. F of x is decreasing, that means that f prime is less than 0. If f of x has a max or a min, then that means that the derivative is equal to 0, because remember, these max and mins, they occur at the critical numbers, the horizontal tangent lines and the vertical tangent lines, okay? And so these are where the derivative is equal to 0. If f prime switches from negative to positive, so that means that the slope went from going down to going up, then that means that the original function has a min. If f prime switches from positive to negative, or the slope switches from going up to going down, that means that the original has a max. Okay, if the derivative is equal to 0, then f of x has a, we can just say a critical number. Really, that's going to be a horizontal tangent line, right? Because the derivative equaling 0 is a horizontal tangent line. The denominator of it equaling 0 is the vertical tangent line. Okay, let's go through to the next slide here. Okay, now I asked you guys a couple lessons ago, I gave you a whole bunch of graphs like this, where they have intervals that are closed. I ask you to find the absolute max and mins. Now if you look at this, you can say an absolute max. The max occurs right there, right? That's the largest y value on this graph. The absolute min would be right here. So notice that the max is occurring at a critical number, and the absolute min is occurring at an endpoint. Okay, so you know here, when you do an absolute max or min, it could be a critical number or it could be an endpoint. So what we're going to do on these is we're going to be checking which is the largest. If it's an absolute max, which is the largest? Is it the critical numbers or is it the endpoints? Whichever one's largest, we're going to say is the absolute min. Whichever one's the smallest, we're going to say is the absolute min. The largest is going to be the absolute max. The smallest is going to be the absolute min. Okay, let's just go through some of this. Okay, so here's how you do it. Step 1 is going to be set up a candidates table. Now, I'm going to explain how to do this on the next one where I give an example. But set up a candidates table. On this candidates table, you're going to include all critical numbers and endpoints. Okay? Find the f prime of x. Now remember, this f prime of x is going to be the critical numbers. And that's the reason why we got to find them, is because we're going to be plugging them into this candidates table. Okay, number 3, plug the values into the original function. This is going to allow us to see which is the largest and which is the smallest, so we know which is the absolute max and which is the absolute min. Okay, endpoints is what people forget about, so don't forget about these. Okay, let's go through here. Let's give this a try. Find the absolute min and max of this function. Okay, so since I read the word absolute min or max, I am going to set up a candidates table. Okay, it's just going to be a table. On this table, I'm going to put an x and a y for my x and my y values, and I'm going to already put the candidates I know. The candidates I know that might be are 0 and 4, because those are the endpoints. Okay, this is my candidates table. I've included my endpoints already. Now remember, I also need to include my critical numbers. So these are my endpoints, and now I need the critical numbers. Okay, now if you notice, I put a graph here so you can check your work, but this would not be given on the test. Okay, let's find the critical numbers. That means I need to take the derivative of this, set it equal to 0. So the derivative, bring this down, it's going to make it 6 over 2 x to the half minus 3. And that's the derivative, right? Let's rewrite this a little different. 3 square root of x minus 3. 6 divided by 3, square root of x is the half. Okay, now I'm going to set it equal to 0 to get my critical numbers. Okay, I'm going to add the 3 over, so I have 3 square root of x equals 3. Divide by the 3, so I got square root of x equals 1. And then square it. X equals 1 squared is 1. Okay, this is the only critical number I got. And if you look at the graph here, that is where there's a critical number, right? That's where the slope is 0. So I only have one critical number, and it's 1. So I have all this wasted space here. You can ignore it. Okay, my candidates table consists of 3 numbers. I need to see which one gives me the largest number and which one gives me the smallest number. That's what I'm going to call the absolute max and min. Now I need to check which one's the largest based off of the y value. So I'm going to plug into this function right here. So let's do f of 0 and see what that gives me. 2 times 0 to the 3 over 2 minus 3 times 0 minus 5. Oops, I don't know why I'm putting parentheses there. Okay, that's going to be 0 minus 0 minus 5. That's going to be negative 5. That's my y value here. And let's check it. At 0, the y value is negative 5. Perfect. Okay, let's check it at 4. F of 4. 2, 4 raised to the 3 over 2 minus 3 times 4 minus 5. Okay, this one's going to be a little bit more difficult. Okay, I'm going to do the square root of this 4 first, which is 2. Okay, and then I'm going to cube it. You can do either one of these first. I could have done 4 cubed and then the square root of it, but I feel like square rooting 4 is easier first. So I'm going to do the square root of 4, just 2. Cubed is 8 times 2. It's going to give me 16 for this term, minus 12 minus 5. Okay, that's going to be 16 minus 17. It's going to be negative 1. Okay, so negative 1 is going to be the answer here. Let's double check it. The y value at negative 4 is negative 1. Now notice, I had to graph this whole function just because my graphing calculator won't allow me to ignore stuff. But here, this is all ignored. I only have this interval right here from 0 to 4. That's all I'm focusing on. Yeah, that's what it says right here, from 0 to 4. Now let's plug in the critical number and see what we get for that. F of 1. Okay, that's going to be 2, 1 raised to the 3 over 2 minus 3 times 1 minus 5. That's going to be 1 to the 3 over 2 is 1 times 2, which is 2, minus 3 minus 5. That's going to be negative 8. Well, this is negative 1 minus 5. That's going to be negative 6. Let's check it. At 1, the y value is negative 6. Okay, cool. Now we can tell where the absolute min and maxes are. Just look at, okay, absolute min. That's going to be whichever one has the smallest y value. Right there. Absolute min at x equals 1 with a value of y equals negative 6. That's your absolute min. And you can look at this graph and you can tell at 1, negative 6, from just the 0 to 4, this is the smallest value you have. It's the lowest on the graph. Okay, now let's see where the absolute max is. Absolute max at x equals, well, if you look at the graph, it's going to be occurring over here. Let's see if that's what our table tells us. Yeah, negative 1 is the largest out of these values. So there's an absolute max at 4, x equals 4 with a value of y equals negative 1. And there's your absolute max. Okay, that's how you do these. So if you ever see the word absolute min or absolute max, there's going to be an interval they're going to be telling you. You're going to set up a candidates table. You're going to put those endpoints on that candidates table. You're going to find the critical numbers. You're going to plug all those x values into the original to see what the y values are. That's it.